Something we have mentioned while working with Haskell is the notion of referential transparency. That means that once something is defined to be a value, it has to have that value until the end of the program. So if I assign a value of x in my script to be equal to 5, I can't later say that x is now equal to 10. So what does this restrict us from? This restricts us from having what we call side effects in programming. Now this is things like being able to mutate state. This could be input-output operations, this could be throwing exceptions. So you might think that Haskell is really quite restricted. If we can't do these things known as side effects, and we can't mutate state, we can't throw side effects, or we can't throw exceptions or handle input-output, then what good is this programming language? Well, as it might not surprise you to learn, Haskell of course does have a workaround. And today we're going to have a look at how we might handle exceptions in one certain way. So what do we do if we know a function might misbehave? Well, these are functions that we know are known as partial functions. You may have seen these before, but this is something of the type f maps x to y plus 1. So these are just arbitrary types, but the plus 1 is the important thing. So you might map something in x to something in y, or you might map something in x to the 1, which is the exception. So these are for where values are undefined. So you could think of this as, for example, the function 1 over x. That is partial application because it is undefined when x is equal to 0. So that's all a partial function is. It's something that doesn't necessarily have a corresponding value to map something to on the other side of the function. So I've got a little function here, just called func, and if I reload and I call function on something like 1 to 5, it does as we would expect. You can see the definition up here. It takes the head element out, that's the first element, and then tuples that with the rest of the list. So you can see here for the list 1 to 5, it takes out the 1 and returns 2, 3, 4, 5. Now that's fine. However, if I try func on the empty list, I get an exception. And that's because head and tail are partial functions, because they do not have a definition necessarily on the empty list. And this is one reason as well why we would use pattern matching over extracting head and x's and tail x's. You could look at this as being somewhat similar to x cons x's. However, if we pattern match in that way, then we are fine to avoid the error. So this is why we would use this. Also, it's less clear to write this out than it is to write x cons x's. However, that's just an aside. So what do we do in this instance? Well, we're going to turn to a new type, a type we've not seen before, called maybe. And I'm going to get the definition of maybe up for you here. So you can see it's defined as a lot of instances of things, but essentially data maybe a is either nothing or it is just a value of a. So up here, this plus 1 would be the nothing case. That's when we have nothing to map something to. So what do we do to use this type? Well, first of all, we're going to have to change our type signature. So we want to use this to define the case where we should just return nothing. That's our error value. And we want to define the case where we have just a as a value. So what we can say up here is we maybe will get an a, and we will maybe get a list of a's. We're not sure yet, that'll happen at runtime. So let's see, if we have a function and we have the empty list, what we should return is nothing, comma, nothing. And then in this case, when we have something else, what we should return is just head x's and just tail x's. So what this allows us to do is by wrapping this thing in a constructor, that's what the nothing, if I could spell nothing, that's what the nothing and the justs are, they're just type constructors, but by wrapping the type that we have in a constructor, we can still return values. So we can still return the nothing, and we can return just when there is something for us to return. Now you could also decide, oh well, actually I should return a default value. Maybe if you're working with a list of integers, you might return 0. However, if you're working within a list of integers, you can only work with integers. Here, we are still keeping the type abstract. We're still leaving it as just a nothing, is allowing us to wrap that in something that can handle the error for us. So if I save this, and I reload, I tend to forget to do that, and I do func on this, now I get nothing and nothing out. And if I do func, and I give it a list 1 to 5, then I get just 1 and just 2, 3, 4, 5. So this has wrapped our code and allowed us to sidestep the error. So this is one way that you could handle an error using Haskell, is using the maybe type. Now, of course, if we wanted to, we can raise things to maybe types. So we could say if we have something of type A, then I want to give back a maybe A. Because if you're just given a value for a value x or something like that, you might want to raise it to the maybe type so you could apply other functions on it. And to do that, all you would need to do is, for a value x, return just x. Because it's only on the right hand side that I might have a maybe type. When I'm on the A side and the input side, I know I'm going to get a value. So now, if I use this function, this toMaybe, then I can apply any function that works with maybe types after applying this to a value. So this is just a way to raise something to the maybe type. Now you could do this with other types, of course. This is just one example. But let's have a look at how we would apply a function for a maybe type. So let's say we have a maybe A, and we have a function from A to maybe B. So that would be like this type up here. This is something that could fit in here. And we want to return a maybe B. So what would we do in this scenario? Well, because we know the type that we're working with, we know that it's a maybe type, what I can say is if I have nothing, then I should return nothing. That just makes sense. So I'll need to give it a function in there as well, f, because there's nothing for me to apply f to, because f doesn't work on maybe types. F only works on A's and converts them to maybes. So this could be like if you're working with, maybe you've done a long series of calculations and you might get a value out and you might get nothing out, and then you want to divide it 1 by that number. So say you do a bunch of calculations, then you want to do 1 divided by the result of that calculation. That type of function wouldn't start with a maybe type, but it could result in 1. And this is the behavior you'd want to encode there, just to make sure that you don't, that you return something that can be handled when your code executes. Similarly, if I have just x and a function, then what could I do? Well, there's several things I could do. I could use this toMaybe function, but since this just wraps a value, then I don't really need to do that. What I can say is because this value here has been pattern matched over, because I have just x, then I can say f of x. So this is sometimes called the bind. This is something that's allowing us to raise our functions to the level of this maybe type. So we can, by pattern matching over the input like this, we can just define what should happen, and this just should hopefully make sense. Now f of x here could return a maybe type, so our types match up, in which case we're fine. Now, if you were to not pattern match over here and you were just to say something like f of a, then you would get an error at runtime when you try to load this in, because it doesn't know if f can apply to that because it's an a rather than just a. So this would now compile. So this is one way that you could define this application of this maybe type to functions that could result in an error. This is one way of handling errors in Haskell. The maybe type is fairly prolific. You can see it in quite a lot of places. But all you really need to understand is how to interact with the value in an appropriate way. And generally, using this sort of notation makes it very easy to work with, which is why it's quite a popular type to use. Because as long as you pattern match over it, you can immediately access the value that's being wrapped when there is a value to access. So this makes life a lot easier. And it's very easy to raise types to the maybe type as well, as you can see here. But all I want you to get to understand from this is there are types that can allow you to handle errors at runtime. You can wrap your functions in these types and it will avoid your code crashing. So that you could think of this in a similar way. It's not quite the same, but you could think of it as throwing exceptions in Java. So instead of just allowing your program to crash, you can wrap things here in the maybe type, and if you define your code appropriately, you should be able to avoid these issues. Of course, you can convert back from the maybe type to the type that you're working with. So if whatever this is, maybe b, see if this was an integer, you could always define some value of nothing. You could say that nothing gets converted to 0 or something like that, and just a just gets converted to a. You can, of course, return back from the type if you so wish, if you have some default behavior for the nothing value. That's everything for today. I just want you to understand that this is a type that we can work with. We'll be seeing another way of handling errors, probably the either type. That's another type that's similar to maybe in a lot of ways. I hope you found this useful. If you have any questions about this, please do get in touch. Thanks.